All right, let's look at a simple example for conservation of energy of a dropped object. All right, so if you imagine a hand up here is holding the ball and drops it, I want you to copy down four positions, and basically everything on the page actually. Title, dropped object, position A, B, C is lower, and then D will be your lowest just before it strikes the ground. We indicated that there. All right, so for each position, there is a box with KE, GPE, and total energy. And your job is to fill in all the blanks in the box using this equation that the GPE and the KE add up to make the total energy. And remembering that the total stays constant. All right, so pause the video real quick, copy down everything on the page, and even the little bit that gets cut off there as well. And that's the ground. And then you could restart it and we'll do the problem together. Okay guys, so hopefully you've copied it down now and we can finish this problem together. You could see letter A is the tallest position, and there's a GPE given to you. You don't have to calculate it. It's just given to you of 10 joules. B is a little lower. The GPE is 8. C is a little lower. The GPE is 2. And then D tells you nothing, pretty much. So one thing we could start with is that at letter A, actually, at letter A, it starts at rest. So the velocity is 0, which means also that the KE is 0. So when it starts at rest, you could assume the KE is 0. All right, so what could we figure out now? For letter A, we know the KE is 0 and the GPE is 10, so we could add those two together using our formula. 0 plus 10 gets you the total, so the total is 10. Now once we know the total at one of the positions, we know that the total stays constant. So in this case, it's going to be 10. In a different problem, you might figure out the total is like 20 or something like that, and then that stays constant at 20. But in this case, the total is going to stay 10 joules at all the positions, so please write that down. Whatever the total is at one position, the total is the same at the other positions. That's what stays constant means in your notes. All right. Now, letter B and C, it looks like we only have one missing blank. So let's see how we could figure out what the KE is at letter B and then at letter C. All right, so for letter B, we could use our formula. Total is GPE plus KE. And if we rearrange that formula to solve for KE, let's take away GPE from both sides. It cancels on the right, and the KE we could say is the total minus the other part, GPE. All right, and we could write the formula like that. So if you take the total and you take away 8, which is the GPE, you're left with the other part of the total, which is the KE, which is 2. In other words, what plus 8 gets you 10? 2 plus 8 gets you 10. All right? And we could play that game without so much math or writing down. We could play that same game with letter C. Actually, you know what? Change that to 3. Make it more interesting. We could say, what plus 3 gets you 10? 7 plus 3 gets you 10. In other words, we did 10 minus 3 to get the missing part, which was the kinetic energy. Now for letter D, we have 2 missing blanks for letter D. All right? But because it's just before striking the ground, we could assume that the height of that position is 0. And that means that the GPE is, since it's very low to the ground, the GPE is going to be 0 because it has no height at all, basically. All right? So then we're going to play that game again to get KE. We're going to say, what plus 0 gets me 10? What plus 0 gets me 10? Oh, 10 plus 0 gets me 10. So, or in other words, 10 minus 0 gets you the kinetic energy. If you you just have to make sure KE and GP add up together to make the total. All right, good job, guys.